Okay, so you want to start by making sure that each side is simplified. See, you don't want to start moving things over across that equal sign as far as eliminating or getting rid of something until each side is simplified. I actually compare it to going to war. Like if two countries are going to go to war, you don't need to go to war if your country doesn't like each other, right? I mean, like if you're America and Americans are in this civil war themselves, they don't need to go to a war with another country. They need to get their arguments under control, agree, like each other, and then they can start killing other people. Okay, so let's simplify each country. So each side, so negative 5c plus 15. And then a lot of people are going to want to distribute this negative 5 to that negative 3, but it's this one right here is not inside the parentheses. So I'll only distribute the negative 5 to the c and to this negative 3. So this just kind of gets copied, pasted. So I've done a little bit of simplification there, but I'm probably not done. Let's keep going to the other side. 33, copy, paste it down. This is basically a negative 1 that we're distributing. So negative 1 times c is negative c. Negative 1 times 1 is negative 1. So let's reevaluate our countries, okay? On the left, 5c, 15. I can do 15 minus 3. And so when it's on the same side, you're combining like terms. You're not doing the opposite or like canceling something out. You're combining. I mean, that's part of the peace process for your country, okay? So negative 5c, 15 minus 3, 12, I think. That's as simplified as that gets, okay? I've trained them up enough. 33 minus c minus 1. 33 minus 1 is 32 minus c. Okay, let's start the war. Okay, so eliminating, I call it killing people, but whatever. So c plus c, you do the opposite, right? So negative 4c plus 12 equals 32. Now, I like my variables on the left and everything else on the right. It doesn't really matter what side the variable's on as long as it's on a side by itself. I just like that side to be the left side. Anyway, so 4c is on the left side. That's great. There's not a c on the right side anymore because I moved it. But 4c is not by itself on the left side. I mean, it's, for one, multiplied by negative 4, but it's got 12 added to it. Before I start dividing by negative 4, see, negative 4 and c have this close relationship. I need to get rid of the baggage before I start meddling in the close relationship. So subtract the 12, and we get what? 20 equals negative 4c. And now we can just divide both sides by negative 4 to get c equals negative 5. And you would just, for your answer, click the set notation, and it'll look something like a set of negative 5. I will say on this problem, a lot of people are guilty of, instead of moving this negative 12 over, like the positive 12, eliminating it from the left side and moving it to the right, a lot of people would have subtracted 32 instead, which is not wrong. It's just not efficient, because if you subtract 32, then you would have negative 4c, and then 12 minus 32 is negative 20 equal to 0. And you wouldn't have c on one side by itself. You would have a whole nother step to do. So it's just more efficient to go ahead and get rid of the 12, so that 4c will be by itself. Then you can just divide by negative 4. With this one, first of all, it's a quadratic. T squared, 22t minus 5. That squared with that t makes this a quadratic. It's the highest power is 2. It also tells me that we're going to have 2 answers. So if like the highest power were 3, we would have 3 answers, and so forth. Anyway, this says to solve by completing the square, and that's what I'm going to end up doing. But let's talk about quadratics for a second. Quadratics you can solve 3 ways. Well, at least 3 ways that I know of. by factoring it. But factoring doesn't always work. In fact, it wouldn't work in this case. Not everything factors. Some things are prime. You can complete the square, which is what we're going to do. But sometimes completing the square is it's just a little. It's not efficient. Okay, and then you can always use the third option, which is the quadratic formula. The opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and you know what? Real quick, I'm gonna do that with this one, even though that's not what it's asking me. I am going to show you the completing the square as well. But so this is in the form of ax squared plus bx plus c. So b is 22. Opposite 22 would be negative 22, plus or minus the square root of b squared. So 22 squared is 484. Minus 4 times a is 1, c is negative 5, all over 2 times a. So let's look at this a little bit further. I want to simplify the inside of that square root. Whoa, Johnny, I messed up, y'all. 2 times 1, okay. Negative 22 plus or minus. So you got to be careful right here. 484 minus 4 times 1 times negative 5. So basically, you got a negative, a positive, and another negative. You got two negatives. Basically, you're going to be adding something to 484. You're not going to be subtracting it because there's two negatives. So 4 times 1 times 5 is 20. So what is that? 504? All over 2. Once you get the inside of that simplified, you want to make sure that your square root itself doesn't simplify. So the square root of 504, is there a square root of 504? I don't think so, but double check that. There's not. So take 504 and write all the factors of 504, all the prime factors, like 2 goes into 504 252 times. But 252 is not prime. 2 goes into 252 126 times. But keep going because 126 isn't prime. 2 goes into 126 63 times, but 63 is not prime. 3 goes into 63 21 times. 21 isn't prime. 3 goes into 21 7 times. 7's prime, I can stop. So instead of writing the square root of 504, I can write the square root of 2 times 2 times 2 times 2 times 3 times 7. Everything that's on the end of one of those forks, basically. So 2 times 2 times 2 times 3 times 3 times 7. And if you have something that happens twice, you can bring it out once. So you bring a 2 out, you bring a 3 out, and then what's left over that doesn't have a partner repeating twice, you leave on the inside. So that is 6 square roots of 14. So I'm going to replace the square root of 504 with 6 square roots of 14 all over 2. Once I get here, I look at the number in front of the square root, the number in the very front, and the number in the denominator. I kind of always visualize a triangle in between the three. If those three numbers have a common factor, okay, and also notice I'm not looking at what's inside the radical. I could care less at this point at what is inside of the radical. I'm looking at the number in front, the number in the very front, and the number in the denominator. If they kind of have a common factor, reduce it by that factor. They have a common factor of 2. Everything gets divided by 2. 22 divided by 2 is 11, plus or minus 3 square roots of 14, and you are done with that. That's the answer. You can always use the quadratic formula. I say perfect the quadratic formula, and then, learn the other stuff, but you're not always able to use it, okay? Even if it says complete the square or you solve using factoring, you can use the quadratic formula if you're really good at it. Anyway, so I am going to, however, complete the square. So let's see. What I would do, I would say t squared plus 22t. And you want to leave that a term and that b term on the left side, and you want to put the c term on the right side, so you're going to move it over by adding 5 to both sides. You take the b term and you half it, you square it, and you add it to both sides. So half of 22 is 11. 11 squared is 121. I got to add 121. Whoa, Johnny, I'm a little dyslexic. I'm so sorry. 121 to both sides. So on that right side, you just say, 5 plus 121 is 126. Okay, but on the left side, what you've done by completing the square is created a perfect square trinomial. And perfect square trinomials factor very easily. They're always half of this number squared, basically. So half of 22 is 11. And what I'm saying is t plus 11 and t plus 11 is what this factors into, because 11 times 11 is 121 and 11 plus 11 is 22. However, I don't want to leave it written as t plus 11 times t plus 11. I'm going to write it as t plus 11 squared, because now I'm going to be able to solve this thing using the square root theorem or something like that, rule. Saying take the square root of both sides, you'll be left with t plus 11 equals, when you inflict a square root on something, there's positive and negative consequences, 126, okay? So we're kind of where we were at with the quadratic formula, in that I need to simplify the radical of 126 if it does. There is no square root of 126. 126 is 2 times 63. 63 isn't prime. 63 is 3 times 21. 21 isn't prime. 21 is 3 times 7. So the square root of 126 can be written as 2 times 3 times 3 times 7, which is 3 square roots of what's left is, when you bring the 2 3's out, the group of 3 out one time, you're left with 2 times 7, which is 14. So I'm going to replace the square root of 126 with 3 square roots of 14. And then since we're looking for just t, we're going to subtract 11 from both sides and get t equals negative 11 plus or minus this 3 square roots of 14. And so now, if you will look, you should have the same answer for both, but it looks like we don't, and I see my problem with the quadratic formula. I forgot the negative with the 22, so, it can happen to anybody. Just don't let it happen to you. Now they're the same. Okay, so we gotta solve this polynomial. It's a 4th degree polynomial. Technically, it could be considered a quadratic, because this x to the 4th could be written as x squared, but we won't go into that right now. I will say this: it does have 4 answers, right? That 4th power. So let's talk about quadratics for a second. I mean, we can factor them to solve them. We can complete the square. We can use the quadratic formula. Let's try the factoring. When you're factoring a trinomial, you're wanting to multiply. You want to find out what multiplies to give you this negative 19, but adds to give you negative 18. Okay, I'm going to pretend for a second that this is a different trinomial. I'm going to pretend that it's x to the x squared minus 18x minus 19. That's kind of a little bit more what we're used to. So things that multiply to give us negative 19 but add to give us negative 18 would be positive 1 and negative 19. If you were, again, factoring this fake trinomial, well, it's not fake, but the trinomial that I made up, this would be your factors: x plus 1 and x minus 19. And if you were solving it, you would set it equal to 0, and you would get an answer of negative 1 and positive 19. However, that's not the problem that we were given. But let's talk about the similarities. I mean, all your A term, your B term, and your C term are the exact same. The only thing that's different is this fourth degree, and this is a second degree. But look at how this second degree factored. I mean, x times x is x squared. X times x is x squared. So our fourth degree will factor into x squared plus 1 and x squared minus 19. Okay, so the same two numbers were chosen. It's just, it's not x and x, it's x squared and x squared. So now we're going to set these equal to 0. X squared plus 1 equals 0, and x squared minus 19 equals 0. So let's get x squared by itself. That's negative 1 equals x squared. That's great, but I need x, not x squared. So use that square root rule. So square root undoes the square, and you're left with x equals. Now, whenever you inflict a square root, you're in plus or minus consequences, remember? Okay, so plus or minus the square root of negative 1, except for you can't take the square root of negative, right? So that just ruins our day because I don't know what to do. No, actually, just bring the negative out as an I and leave the number on the inside. So I square roots of positive 1, plus or minus I square roots of positive 1. And over here, you get 19 equals x squared, and we're going to do the square root again. You get x equals plus or minus the square root of 19. You don't bring an I out or anything like that because it's a positive 19 that you're taking the square root of. You do want to look and see if the square root of 19 simplifies. But 19 is prime. The whole groups of 2 and bring the group of 2 out once, that wouldn't work with this because 19 is prime. I mean, nothing else goes into it. So there are our 4 answers. I square roots of 1. Wait, what a crazy guy. What's the square root of 1? 1. So 1 times I is just I. So I, negative I, square root of 19, and the negative square root of 19. We're solving again, okay? And so you got a polynomial. We've had fourth degree polynomials where we have 4 answers. We've had second degree quadratics where you have 2 answers. This is a cubic. This is third degree. We're going to have 3 answers. And I mean, some of the ways that we've been solving problems so far, I mean, we've done factoring, completing the square, we've done quadratic formula. I mean, this is not a quadratic. You can't use the quadratic on a cubic. So let's try factoring, okay? But even the factoring, this is still different because this is not a trinomial. This is a 4-term polynomial. But I really like factoring 4-term polynomials because all you gotta do is group the front and the back. And now, if I were on a whiteboard and this were live in person, I would put my hand over. In fact, let me see if I can change my utensil. Maybe this, I guess. I would put my hand over that guy, okay? And I would forget about him, and I would think about person on the left, okay? 80b cubed and 48b squared. You want to look for a GCF. 80 and 48. I think 8 is the biggest number that they have in common. Let me just double check. Actually, it's not 16. So 80 divided by 16 gives us 5. And 48 divided by 16 gives us 3. But they also had a b in common, and you're going to take out the lowest power of b that you see, so a b squared. And if I take a b squared away from b cubed, you're just left with b. If I take a b squared away from the 48b squared, you don't have a b anymore. So now I forget about this guy, and I would be putting my hand over him, and I think about this. 45 and negative 27. Negative 45b and negative 27. First of all, the leading coefficient is negative, as in the negative 45. I want to take out negative, and I think 9 is our biggest number that we have in common. There's not a variable that we have in common. So negative 45 divided by negative 9 is positive 5. And negative 27 divided by negative 9 is positive 3. Well, look, if you've done this correctly, those insides are the same. So now they both sides have a 5b plus 3 in common. If you take a 5b plus 3 out, you're left with 16b squared minus 9. I will say, this is not fully factored. This 16b squared minus 9 is actually a difference of squares, so that would give us 2 more binomials, and we could set all 3 equal to 0 to get our 3 answers. Or you can just say 5b plus 3 equals 0, subtract 3, and get 5b equals negative 3, and get b equals negative 3 over 5. And you can leave the 16b squared minus 9 as it is and just say 16b squared minus 9 equals 0, 16b squared equals 9. And then if you want, you can then divide both sides by 16. Get b squared equals 9 over 16. Let me erase that. 9, come on. 9 over 16, and then take the square root and realize that it's plus or minus 3 over 4. There's your 3 answers. So, yeah, there's fractions on this, but that's not what I'm really concerned about right this second. I'm concerned about getting the absolute value. I mean, solving for t, obviously, but it's inside the absolute value. So I need to get that absolute value by itself. So why is it not by itself on that left side? Because it's got a negative 1/5 subtracted from it. So add 1/5 to both sides. And our calculator can do this nicely for us. You just want to put, 1/2 plus 1/5 and put your fraction in parentheses, basically, in the calculator, and you can change that that decimal that it gives you into a fraction. Anyway, we get 7 over 10 when we do that, and that will equal the absolute value of 3 minus 1/3 t. So now that the absolute value is by itself, I can get rid of it by creating 2 equations. One basically copying, pasting the original without the absolute value bars, and the other writing the same thing down except setting it equal to negative 7 over 10. So opposite, like if it started out negative, change it to positive, and so forth. So I want to solve for t. I will subtract 3. And let me just, I guess, show you what I'm doing here on the calculator. Okay, so we got 7 over 10 minus 3, so we'll just say parentheses 7 divided by 10, close parenthesis, minus 3. Press second, FD. That's a mixed number, negative 2 3/10, and then press second, and the key underneath it, ABC key, to get negative 23 over 10. So negative 1/3 t equals negative 23 over 10. So now you can either divide by negative 1/3, or you can think of it as multiplying by the reciprocal. Okay, I'm just gonna, since I've been doing it in the calculator, divide by negative 1/3, and you get t equals 6.9, or 69 over 10. And then this one is worked the same way. You're just going to want to use that calculator for your fractions. You would end up getting that t equals 111 over 10. So we need to solve for x, and you know, that's great and all, especially with this right side. This right side looks amazing. But on this left side, our x is trapped inside of a square root, right? Well, I mean, what you do when something's trapped? You get it out. And the way you get out or get rid of a square root is you square it, okay? But you know what you do to one side, you got to do the other. It's only fair. So now that I've squared that left side, we don't have a square root anymore, and we just have 19x plus 118 equals, okay? We got to simplify x plus 8 squared, and it's not simply saying x squared and 8 squared. When you square something, you multiply it by itself. Think about the number 9 really quickly. 9 squared is 81, because 9 times 9 is 81. Well, x plus 8 squared is x plus 8 squared times x plus 8 squared. What an idiot. X plus 8 times x plus 8, sorry. Anyway, and what we've written down, that's great, but it's still not good enough. It's not completely simplified. I got to FOIL this out. So x times x is x squared, x times 8 is 8x, 8 times x is 8x, and 8 times 8 is 64. So that even goes further into x squared plus 16x, because 8 and 8 is like terms, plus 64 equals 19x plus 118. So we should be done by now, right? Because we've done a lot of work. But that's not the way life works. Okay, so let's see. Looks like this is a quadratic, because our highest power is something squared. And quadratics, I like them to be set equal to 0, because from there, once it's set equal to 0, I can use the quadratic formula or complete the square or factor it or whatnot. Well, be careful when you're setting equal to 0. Like, it's probably going to be your nature to want to move everything to the left side. That's my nature. I like variables on the left side. But right now, this x squared is positive, and I like that it's positive. If I move it over to the left, it becomes negative, and then it just becomes complicated to work with for me. So I'm going to move this the left side over to the right. And we get something to the tune of x squared minus 3x, and 64 minus 118 is negative 54. So we got lots of options. It's set equal to 0. We got some options to choose from. I'm pretty decent at factoring, so I like to factor it, or at least try it. And if you spend more than 3 seconds looking at it trying to factor it, you might want to just go to the quadratic formula, because you might not be that great at factoring. But factors of negative 54 that add to give me a negative 3. First of all, if you're multiplying to get a negative, your signs have to be different to get a negative. If you're multiplying to get a negative. If you're adding to get a negative 3 in the middle, then your larger number between the two different sign numbers needs to be negative if you're adding to get a negative. So 54. What about 6 and 9? The larger needs to be negative, the smaller would be positive. If you multiply positive 6 and negative 9, you get negative 54. If you add them, you get negative 3. So let's actually write that down. And so now we're going to actually set them equal to 0, and the signs completely change once you do that. So there are your two answers. I'm actually going to start recording as I'm writing this down, because the way you read it is just a little wonky. Okay, so this is 5 times the 5th root of 5w minus 2 minus 7 equals negative 17. So guess what? We're solving it. And we're solving it for W. And W has a lot going on with its life right now. It's got a lot of things that's holding it down. So I gotta go from the outside in as far as getting to W. Get get rid of like all the big stuff on the outside of it and just focus inward, inward, inward. Pretty much I want to isolate that fifth root. The way I'm going to do it, start it, is by adding 7 to both sides. So you get negative 10 equals 5 fifth roots of 5w minus 2. So that's great. It looks a little better. Not much, but is the fifth root isolated? Does it say literally the fifth root of something equals this? No, it doesn't. It says 5 times the fifth root. So how do you get rid of that 5? Well, it says 5 times, right? So what's the opposite of multiplication? Division. Divide by what you don't want. You don't want the 5 there. So the fifth root of 5w minus 2 equals negative 2. So now that the fifth root is by itself, you got the fifth root of 5w minus 2 equals negative 2. To get rid of the fifth root, I mean, think about it really quickly. You wanted to get rid of this 5 earlier, and it was being multiplied, so you did the opposite. You divided. Well, to get rid of the fifth root, you do the opposite. You raise it to the fifth power. And what you do to one side, you must do to the other. That's only fair. So we're just left with 5w minus 2 equals negative 2 to the fifth power. Negative 2 multiplied by itself 5 times, but your calculator will do a fifth power for you. This is negative 32. So now this is great. Right? It's negative 30 equals 5w divide by 5. You get w equals negative 6. So I'm about to work these two rational equations. I'm about to solve them side by side because I want to talk about their similarities. Now, I am going to start with the one on the right. It's a tad bit more complicated, but not really, okay? And hopefully by looking at the one on the right first, it'll make the one on the left make a little bit more sense. You want to first, I mean, we got to get rid of the fractions. We're going to do that by finding an LCD, multiplying the whole thing by the LCD. The fractions will cancel out, and we'll just have this, nice flat little thing, okay? So in order to build that LCD, you want to make sure these denominators are completely factored. Q plus 4, factored. Q minus 4, factored. Can't do anything to it. Q squared minus 16, it's not factored. It's a difference of squares. I'm going to not think of Q squared minus 16 as the denominator. I'm going to think of it as Q plus 4 and Q minus 4. So now the denominator is completely factored. I'm going to go to the side, build my LCD the way I built it. I work from left to right, just like you read a sentence from left to right. I copy and paste the denominator that is on the far left. So I go ahead and copy paste Q plus 4. Okay, I've gotten that guy taken care of. I then look at the guy over here. I say Q minus 4. Do I have your back yet? Are you in the LCD? No, you're not. Q plus 4 is, Q minus 4 is not. Okay. So I've gotten this guy taken care of. I've gotten this guy taken care of. Let's worry about this guy on the other side, right? Q plus 4, are you in there? Yes, you are. Q minus 4, are you in there? Yes, you are. So let's multiply the whole thing by Q plus 4 and Q minus 4. I like to write it on the top of every fraction. Some people put parentheses around it and put it out front. That's great and all. I like to write it on the top of every one. It holds me a little bit more accountable. So, a question to ask yourself really quickly, what's 1 divided by 1? Well, it's 1. What's 4 divided by 4? It's 1. Anything divided by itself is 1. No different with Q plus 4 and Q plus 4. It cancels, it's 1. So all you were left with is the numerator of 3 and Q minus 4. So 3 times Q minus 4. You're always left with a numerator, by the way. Like on this other one, 2 over Q minus 4, I can go ahead and write the 2 down. You're always left with a numerator. Anyway, Q minus 4 cancels. So you're left with that 2 and the Q plus 4 equals, look here, this is great. The whole thing cancels, negative 13. So all you gotta do from here is just do things that you should already know how to do. like distribution. You know what would be horrible? To do all of that junk right that I just did and then screw up this part. That'd be absolutely horrible. People do it though. If I'm not careful, I'll do it. So we end up getting 7. The only thing you want to do at this point is make sure that that number that you solved for, that you got, doesn't make the denominator 0. And 7 plus 4 is not 0. 7 minus 4 is not 0. 7 plus 4 times 7 minus 4 is not 0. So the answer of 7 works just fine. Okay, so there we go. Now, let's compare it to this. Now, right here, I factored first the denominators, then I built the LCD. Let's look here. Does 3 factor? Of course not. 3a, no. A, no, not at all. So there's really no factor in the denominators there when your denominator is so simple. But building the LCD to me is just about the same thing. I work from left to right. I copy paste the denominator on the far left, so the 3. And then I say, okay, 3, are you in there? Yes, you are. A, are you in there? No, you're not. Okay. So I've gotten this guy and this guy taken care of. What about you? A, are you in there? Yeah, you are. So multiply the whole thing by 3a. So now your 3's cancel. You're just left with 1 times a is a. Your 3a cancels, and you're just left with minus 5. Your a cancels, and you're left with 3 times 6, which is 18. So add 5 to both sides and get 23. And you do want to check and see if 23 makes the denominator 0. Well, you can't plug it in there, and 3 times 23 is not 0, and 23 is not 0. For this one, we got 3 parts. Absolute value of x equals 6, absolute value of x less than 6 and greater than 6. And you know what? This is one question, okay? However, there are 3 completely different questions inside of it. I mean, you're thinking you answer the first part and you got, you got your answer kind of for the rest of it, and you really don't. You have to think of each of these things individually. So for part A, absolute value of 6. Whoa, what a dummy. Don't do stuff like that. Absolute value of x equals 6. To get rid of that absolute value, just get rid of it. Write down what is on the inside of it twice and says equal to 6, and then change the sign. So that's the answer to A. That's great. But now your life changes. So B, the absolute value of x is less than 6. Okay, well, let me just tell you something. This is a compound inequality. We're going to split this up into 2 different inequalities to get rid of the absolute value symbol. And whenever your inequality starts off as a less than, the compound inequality is an and problem. Okay, and looks for overlap. That means for part C, the inequality starts off as greater than. When it starts off as greater than, it's an or problem. Or problems look for where there's a graph at on the number line. So basically, or problems get rid of blank space. So, you can know how to work an inequality all day. You got to memorize that. Less than and greater than or, if that's the way it starts off. And that can be annoying. That used to annoy me when I didn't have it memorized. Anyway, so part B, it's x is less than 6, and go ahead and write that word. X is what you want to do to get rid of the absolute value bar. I mean, write it the way I've written it once, okay? And then the second time, write down the inside of the absolute value, flip the symbol, change the sign. So here's our number line. Put your numbers in numerical order. First, let me just say this. I highly suggest graphing it. I can't answer this problem without graphing it. I just can't. So, less than 6. Okay, we got 6. We're going to go to the left. And it gets a parenthesis, or what you consider an open circle, because of it just being less than. If it were less than or equal to, it'd be a closed circle or bracket. Okay, x is greater than -6. Let's do this in a different color. So the magic question is, where are the two colors on top of each other? Now, back in the day when highlighters were real and on paper, you could use highlighters and it would be where your color was ugly at, because the two colors would have, bled together. But it's from -6 to 6, right? And you interpret your graph from left to right, just like a sentence in numerical order. So from -6 to 6 would be your answer. Okay, and you might be thinking, oh, well, I can go ahead and do the OR part, right? And on this, for real, if this problem were an OR problem, the answer would be from -infinity to infinity, because there's never a blank space. But you can't just do that for part C. You got to actually go work it. So part C, it says x, absolute value of x is greater than 6. So x is greater than 6, or x is, whoa, Johnny, don't write your absolute value bar. X is, flip the symbol, change the sign, draw a whole nother number line, put your numbers in numerical order, get your highlighter or whatever you need, okay? X is greater than 6, parenthesis. X is less than -6. Parenthesis. So, question, where's the blank space at? Right here. Right there, right? Get rid of it. That's where the U is, basically, where you had to union them together. So read your graph from left to right. Left to right, what happens first? This thing, this blob arrow happens first. So what is that? I mean, you can't just write arrow to 6. You have to write -infinity. What does that arrow mean? -infinity to -6 is where it stops, but then you pick back up from 6 to infinity. And there's your answer.